simplifying rational expressions. So irrational functions when you kind of have exponents in a type of fractional form. Okay, so we have two sets of fractional expressions multiplied by another set of fractional expressions. With the multiplication, you can really just say what I've just done here. You can put a times and I can put everything over, because when you multiply fractions, you do the top by the top and then the bottom by the bottom. So we can actually, I'll make this one confined question. So say the f at x, the function is equal to that. So we get, I'm going to put brackets around just so we know to multiply, minus 19a plus 5 times 2a minus 3. All of that's divided by, same idea, 4a squared minus 9 times 3a minus 1. Okay, so now we have to try to work on simplifying these ideas. The hope is that we're going to get sets of brackets that can kind of cancel out, right? We don't quite have that yet. So what we're going to focus on is trying to factor or simplify some of the expressions themselves. So this first one here, this is a trinomial, so we can factor it. This here is a binomial. It's a difference of squares, so I can factor that too. Here, I can't really do much. I can't even really common factor nicely, so I'm just going to leave these two as is. But I'm going to factor these ones. So the first one, we'll do it in, let's say, red. So we're going to factor that. So think of it like we're just simplifying this over here. We get 12a squared minus 19a plus 5. So decomposition is a usual way of doing this. They sometimes call it like a product sum chart you can make. But essentially what you're looking for is two numbers that multiply to the a and c term. So in other words, whatever 12 times 5 is. And those same two numbers need to add up to our b term, which happens to be negative 19. 5 times 12 is going to be 60. So two numbers that multiply to 60 and add to negative 19. We've got to think of our factors of 60. Like 1 and 60, that obviously is not going to work. 2 and 30, those don't work very well either. 5 and 12 aren't very nice. 6 and 10 don't work. Is it 19 this term?
Yeah. Negative 19.
Negative 19. Oh, negative 19. If I missed any here, let's say 1, 2, 3. What's 4? 4 goes in 15 times. There we go. So we're looking at 4 times 15. That's going to give us 60. Okay. And then 4 plus 15 gives us positive 19. So it doesn't quite work. If I turn them both negative, then that gives us that. And if I turn these both negative, it still equals positive 60. Yeah. So that works out. So these two terms we're going to use to decompose. So 12a squared, and then I'll rewrite it here just so you can kind of see what they mean by decomposition here. We're going to split this term. Instead of writing 19a, we're going to write negative 4a minus 15a. And what we've done is deconstructed the negative 19. If we put those together, we would get negative 19, right? But instead we split it. Now that we split it, we're going to find the common factors of the first pair and the common factors of the second pair. So the very first one, I can take 4a out of each of these, right? I can divide each of these by 4a. So we common factor the both of them. So 4a comes out in front, and in our brackets we end up with 3a. That's what we get when we divide this. Minus 1. And our other one, we can take out 5. And not only 5, because the first term's negative, I'm going to take out negative 5 from each of them. Okay, so I'm going to take out negative 5 just so our first term ends up being positive. So we're going to take out negative 5, and we're left with brackets 3 minus 1. Positive divided by negative is a negative. So that's what's very important actually for us. We need to make sure these two brackets are the same. Once they're the same, the idea is that we're common factoring them, but the easiest way to think about it is we just rewrite the one paired bracket once, and the other bracket we write what's ever left over, 4a minus 5. Okay, so that would be the factors form of that. A lot of work for just that one. This one here is called a difference of squares, 4a squared minus 9. And the quickest way to do a difference of squares is by actually square rooting the first and the second term. We know we're going to end up in a set of brackets. Square root of the first term would be just 2a, so that's going to be the first term in each bracket. Square root of 9 is 3, so that's the second term in each bracket, and then we just put a plus and a minus. So it's a really fast way to factor that. So let's rewrite this whole question now. We have f at x is equal to, we split that 1 value into 3a minus 1 and 4a minus 5. So we replaced, highlight it, we replaced that, the 12a squared minus 19a plus 5, with that idea. And then there was still on top a 2a minus 3. 2a minus 3. Okay. And then on the bottom, we replaced that with these two sets of brackets. 2a minus 3 and plus 3. Okay. So we have 2a minus 3, 2a plus 3, and then there was still one more, 3a minus 1. 3a minus 1. Now, this is most tempting to start doing all of our crossing out right now, so we look for like similar values. So, there's a 2a minus 3, 2a minus 3, 3a minus 1, so those all disappear. We kind of left with this, but it's actually really important that we do the restrictions at this point, okay? And in order to do a restriction, think of it like this. This is some term times some term times some term. Because it's all multiplication, if any of these are 0, we divide by 0. That's undefined. You cannot do that. So we're going to set each of these equal to 0 to look for a values we could not use. So 2a minus 3 equals 0. So to isolate for a, we bring 3 over, and then we divide by 2. So a equals 3 over 2. Or in other words, a cannot equal 3 over 2. Because if it builds a 0, it's no good for us. 2a plus 3 cannot equal 0. When I bring 3 over, it becomes negative. So a cannot equal negative 3 over 2. Is that too fast how I'm finding those, or is that okay?
Kind of, yeah.
Kind of? Okay, so when I do it, I'll do it each step with this last one. 3a minus 1 cannot equal 0. So when we bring negative 1 over, it becomes positive. So we get 3a cannot equal positive 1. And then to isolate by a, we divide by 3. So a cannot equal 1 over 3. And those are the same steps I did there. I just sped up the thing, okay? So these three are our restrictions. A cannot be 3 over 2, so 1.5, negative 1.5, and 0.6 repeated. And those three won't work. And the reason being is if we were to plug them in, we'd get some kind of 0 on the bottom. Now that that's done, this is the best time to simplify stuff. We cross out any brackets that are the same. Those would eliminate. These would eliminate. And then you're left with just whatever's in the middle there. So you have 4a minus 5 over 2a plus 3. So that's a lot of work here. But that big expression we started with can just be written as everything there at the bottom with these restrictions attached to it.